Evening, sir.
Good evening, sir.
Oh, great. It's good to hear. We just
Good evening, sir.
last class. What Chime says active. Let's take Ngozi. Ngozi. Let's from last class.
I'm here. Chimeze
Yes,
is here.
please.
Here.
Ngozi is here.
Okay, Chimeze, you have to hold on. Let Ngozi take us. Go ahead, Ngozi. Ngozi, I can't hear you.
Hello, good evening.
Go ahead now.
Good evening, everyone. From the last class, which was on building fabrics and structures, I was able to take away that the building is made up of certain components, which include the foundation, the walls, the roof, and so on, and that the foundation is a fundamental part of the building. Once you get the foundation right, then a lot of things in the structure will fit in properly. But if you do not get the foundation right, then it could lead to total building collapse at a certain stage in that building. So we have to be very careful when we construct the foundation. And then you told us that there are different types of foundation. We have the raft foundation and so on. And the type of foundation that will be constructed for a structure will depend on the type of soil that we have in that area and the kind of structure that we're going to put on that building. So if it's a bungalow, the foundation will not be the same thing as a 2, 3, or 4-story building. So all those things need to be put into cognizance when we're developing our structures. Thank you.
Yes, very correct. You are really, you took the class very well. Chimeze, let's hear you.
Good evening, all.
Yeah, good evening.
Yeah. For me, my takeaway from the last class is having a broader view about the building of fabrics. It's like a day-to-day thing that we come across. As long as you have a roof above your head, you must definitely come across these things, and how best it is to really manage them. And also there were lots of scenarios that were painted about structural deficiencies and how best it is to manage and control them. Thank you.
All right, thank you. Chris, let's hear you, please. You're taken from last class. Chris, we are waiting for you. You're taken from the last class, please. Chris, you're taken from the last class. Yeah, we're waiting. Unmute yourself and talk, please. Okay, while Chris is at it, let's go to our taken from the last class. Okay, Tosin, are you there? Are you in class?
Good evening, sir.
Hi, good. Go ahead. Good evening.
Yes, my take home from last class is how the foundation, the types of foundation, how it's applicable, the walls, the roofs, the roof defect, and how to go about the to the repairs and when those the one that your son. That was my take on it. So,
Okay, that's good. Christian, please, you're taking from the last class, Christian. Christian Amos. Okay, Christian is not there. Let's just go to the class. So today we shall be looking at we'll be looking at regulatory requirement and building code. Regulatory requirement and building code. Now, whatever is being done needs to be guided in a building, needs to be guided and regulated so that we could have minimum acceptable standards in building management. It's very important for us to know that at every point in time, it is required for us to manage or to coordinate the way buildings are being set up. Hence, the need for a form of regulatory activities or regulation as well. This is to maintain the minimum acceptable standard, which has been agreed both locally and internationally when setting up a structure for people to live, to work, and to play. It's very important for us to know that we must maintain these standards, and these standards does exist. We shall be looking at this discussion this evening on these following outlines. We'll look at the introduction, the administration, the requirement and enforcement, technical issues, building maintenance standard. We'll look at all that as we go through the class this evening. What is a building code? Building code is a set of rules that specify the minimum standard for constructed objects such as building and non-building structures. A set of rules that specify the minimum standard for the construction of objects such as building or not buildings. Usually applies to the engineers and architects designing the building. Also serves as guidelines for safety inspectors. Building codes have been used by governmental units for centuries to ensure that the building remains safe and sanitary. Now, even for designers of structure, it is important for them to manage the way the design works design. And for us as architects, as part of our training, one of the minimum things that we learn is what we call architectonics. Architectonics refers to the different elements of the building and how it is constructed. In terms
So
of
please, the audio is not clear enough.
All that. Oh, sorry about that. Sorry about that. Hello, can you hear me now? Is it clear enough?
Yes, I can hear you now.
It's better.
Oh, great. Awesome.
I can't hear you.
Okay, great.
I can't hear you, sir.
It's still a bit it has some interference.
It's the weather. It's the weather.
I'm sure it's clear enough because I've tested it and it's sounding clear from where I am. So I'm sure probably it's a network that is distorting it.
It's clear now.
Okay, great.
I think it's clear now.
Okay, great. I'm sure it was a network. Anyway, like I mentioned, I said particularly for architects like us, we have several standards that we use for designing a building, and we use the standard height for human beings, which is generic to everybody living on Earth, apart from few issues that happen. The general height of a normal door in a house is normally 2.1 because that's the average height that should be able to manage, that every average human being should be able to do that. After much studies, those things were agreed. So that's the kind of thing that happens on building codes and standard. It's after research and widely covered all over the world, some basic requirements are put in place and then agreed as standards for structures and to be set up as a minimum required standard. You can go above, but at a minimal level, you should actually remain there and ensure that everything goes as it should, so that you don't have a building where it's only meant for short people. Anybody that is not up to 5 feet, that is above 5 feet cannot use the building, cannot use the door. But if you have a 2.1 door, is far above 6 feet, and people that are even above 6 feet can still use that height of door. That also informs the position of the windows, the height of the windows, the sizes of the windows, the materials you use, the size of tiles, this modules that we use for these things. It's also those modules that are used to produce materials that building materials that you have in the market. Except on special orders, you have these materials regularly. For those of us that are conversant with wood production, we will know that for plywood and plain wood, the sizes are generic, whether it is produced in Nigeria, or whether it's produced in China, whether it's produced in US, or whether it's produced in Australia or anywhere. The sizes are standard 1.2 by 2.4, which is 4 feet by 8 feet. That's what they use for the production of those plywoods. That's what we call model, building material model. Tiles come in different forms, in 600 by 600, 30 by 30, 150 by 150, and thereabout. Those are the models that they are produced. Building ceilings come in 30 by 30, 60 by 60, 60 by 120, thereabout. Just those are models that they produce building materials, and these are things that have become acceptable standard. So even the size of rooms also goes along that model, so that you don't have too much wastage when it's being built. That's part of the things that building code will do. Now, types of building code. We have the National Building Code, developed by government agency, governmental standards organization, the governmental standard organization, such as SON, that you know as a song and thereabout. ISO, there are also standards enforced across the country by the federal government. Because it is national, it is restricted to that country. It is restricted to that country. Model building codes. This is where the power of regulating construction and fire safety is vested on the local or subnational authorities. When you're talking about local governments or state government, like Lagos now have some building code that they use for constructions that are made within Lagos State, and they monitor it. Is slightly different from what happens in the General Federation. they localize their own, and that's what happens. They enforce it by themselves to ensure that, okay, buildings built in Lagos State, because of the peculiarity of the landscape of Lagos, the way Lagos is wired, the way Lagos is fashioned, is close to the water, and so and so. If you must build so and so building, if you have dwellings that is above 2 or 3 or 4 home dwellings, you must have a sewage treatment plant to manage the waste that comes out, to minimize the level of septic water that goes into the ground because of the level of boreholes activity that is happening around the state. So those are some of the things that normally happens. Then you have the International Building Code. This is where the power of regulating construction and fire safety is vested in international institutions to which local and national jurisdictions have signed up to adopt common conventions. This is very, very prominent in the aviation sector. The aviation sector use a lot of international codes for what they do, because the activity is more on an international scale. Because you have this international, intercontinental relationship between airports, and airplanes are coming to your airport. They have minimum required standards, and that is required before airplanes can land on your airport. That's why you have some airports that are designated international airports and some others local airports. The local airports may not be able to manage international flights because they may not have the facility to manage, one, the size of the aircraft, two, and the equipment, the computerization equipment that they use to communicate to the aircraft may not be as advanced as that of international airports to aid both landing and taking off. Those are the kind of things that you have from International Building Code. Building regulations parts. Building regulation parts. We have that of structure. Structure, the structural stability of the building. This refers to the structural stability of the building. The area covered include design of foundation, walls, floors, and roofing components. Now, every building code is sectionized into different parts. One of the sections is the structural section, which we have just mentioned now. Takes care of the foundation of the building, the walls in the building, the floors in the building, and the roofing components. Basically, that's what manages. You have the fire safety requires for providing early warning of a developing fire, and also satisfactory escape routes, preventing fire spread both within and to other buildings, providing good access to fire fighting facilities to the fire service. You know, actually, especially for public buildings, commercial buildings, or multi-residential buildings, it is very important to take care of this minimum required standard for fire safety. We want to ensure that there's a form of fire warning, fire alarm system if there's any fire within the premises. That's why there's installation of smoke detectors, which is connected to a panel. The smoke detector actually detects smoke, detects fire in a building, and sounds the alarm as a warning to the inhabitants or the those that are in that building, to ensure that they scramble out for safety before the fire takes over the building, and also to be able to alert the firefighting authorities that there is fire in that building so they can come and fight. Also, it manages the escape routes in case there is fire, to ensure that people are able to move out of the building in good time and not get themselves injured or get others injured in the process. Also prevent spread of fire from one building to the other. Fire can move and spread from building to building if fire safety standards are not adhered to, and also provide good access for the firefighting authorities, fire trucks and all that. So when they come into the building when there is fire, they can access the building and work as it is required. Site preparation and resistance to contamination and moisture. The recommendations of making sure your property remains free from damp penetration, condensation. We've discussed this in the last class. We talked about capillary rise, which is damp penetration. And we talked about some persons had questions on condensation and also contamination that may be in the ground and watertight. Normally, around industrial areas, this becomes very important and very useful to ensure that the contaminants do not go into buildings where residents stay and they don't get infected from taking contaminated water and so on and so forth. Toxic substance guide on the penetration of toxic substance permitting into the building when inserting insulation into cavity in walls. There are sometimes you need to, these standards are normally put in buildings to ensure that if you are building an industrial building, a building that is having a lot of chemicals, so that these chemicals don't penetrate out of your building and then cause hazard to people on the other side. Resistance to the passage of sound. This is sound insulation reduces sound transference between building, between flats, between rooms, and common areas where people dwell. Imagine staying in a block of flats, and then whatever discussion you're having in your house, if people in the less flat is hearing everything, and it's not always very good. So normally, the minimum standard is to ensure that there's a minimum requirement in terms of sound movement to prevent, especially when you have individual apartments that are joined together even by walls, they can have a little bit of privacy. Ventilation. This part provides adequate level of ventilation to buildings and prevents condensation forming in roof voids. Normally, you ensure that you, because when there's change of temperature between cold and hot, after a while, it produces condensation. Driplets of water, it just shows at different parts of the building, either in the walls, the ceilings, or thereabout. Proper ventilation ensures that doesn't happen, and also ensures there's proper free flow of air within the building for the people and the inhabitants of the building to be able to live comfortably, having good oxygen levels in their bodies. It's very important for us to note, and then let's know that. Also, look at the hygiene of the building. Look at the drainage and waste disposal. Look at the combustion and foil storage, protection from falling, collision and impact, conservation of foil and power, access to and use of the building, placing safety in relation to the impact of opening and cleaning, electrical safety, openings and cleaning. You know, when you are building a structure, you must also note that from time to time, the glazed areas, especially places like windows and fixed lights, they're supposed to create access to be able to maintain this aspect of the building. Anyway, that's the job of the architect to actually do anyway. Normally, we'll make that minimum. It's part of the standards and things and concerns that must be given when locating your glass or your windows and so on and so forth. Professional requirements. Now, we're talking about the inspectors that come to monitor a building. The requirements to become an inspector or plan examiner. For you to be an inspector, this is just on the wayside, just for us to note, in case any of us will get the privilege of becoming inspectors. Like in Lagos State, I know that they actually have some professionals they hire to do their inspections for them. One must be at least 18 years old, be of good moral character so that it's not easily bribed, must have minimum of 5 years experience in related field, and he combined post-secondary education in the field of construction or related field will be required. Requirement to become a building code administrator must be 18 years of age and above, of be of good morale, must have 10 years combined experience as an architect, engineer, or a planner, plan examiner, within at least 5 years of such, with at least 5 years of such experience in supervisory position or capacity. It combines post-secondary education in the field of construction or related field. That's if you want to become a building code administrator, you must be well experienced. You must have experienced some of this thing. Purpose of building code. To provide one is to provide or establish minimum standard and requirements for safety, health, and general welfare. Like I mentioned earlier, for general welfare, you need to be, these are the things that it does. It provides safety, health, and general welfare of the inhabitant. To provide certain minimum standard provisions and requirements for safety and stable design, method of construction, uses of the building, uses of building materials or materials in the building and structure, such as cement, the kind of cement that you have to use, the kind of block, kind of POP materials. Those are standards that are specified. Good enough. These things, because of the specification that has been done, the cements are just produced in that standard that makes it a lot easier for us to use them and not get caught in the quagmire of using terrible cements or terrible building materials, which sometimes, especially for finished materials, which sometimes by scope of building code. Standards for structure, placements, sizes, usage, walls assembly, egress rule, that's when you're going out of a building, egress, foundation, roof structure, etc. It also covers rules regarding parking and traffic impact, environmental impact analysis is part of the things that happen. Fire code rules, also that's the standard scope of building code, also covers fire code rules, also covers requirement for earthquake, flood, hurricane resistance. I don't have all that natural disaster apart from flood here in Nigeria that much. So these things cover it. Requirements for specific building uses, energy provision and consumption, specification of components, allowable installation methodologies, minimum and maximum room and exit sizes and location. Qualification of individuals or corporates or corporations doing the work for high structures and anti-collision markers for the benefit of aircraft, for very high, for skyscrapers. If you go around Victoria Island and the Marina, Lagos Island, those high skyscrapers that you see there, if you look at those structures critically at night, you will see lights beaming over those structures. Those lights are the anti-aircraft lights so that aircraft don't run into them when they're flying. It makes the aircraft to know that there's a structure there. Even the masses that you have, telecommunication masts, that these lights are on top of them, that always just beeps so that it alerts the airport, the pilots and those that are flying the plane not to come close for the danger. Building Code Administration, National Building Code of Nigeria, 2006. Nigeria has a building code which is totally being used. It was first enacted in 2006, and presently I know that it's being revised. It's being revised presently so that it can be more like a passing. Aim of building code. The aim of building code is one of them is to set minimum standards on building pre-design and design, construction and post-construction stages, with a view to ensuring quality, safety, and proficiency in the building industry. Objectives of code, building code, to encourage professionals in the building industry to produce the most appropriate code suitable for our environment, for their environment, wherever they find themselves. Yes, there's an international code, but the local code is produced to meet up with your local need for also subsequent use and application. These codes is ensured, they make sure that each things that are done according to the code, you can replicate them anywhere without having any problem. It just gives you the minimum required standard to ensure that the quality is given as it should be. Scope of building code applies to and control all matters concerning design and specification, costs, construction, alterations, additions to, moving, demolition, location, repair, and use of any building or structure for existing or proposed building works within a Federal Republic of Nigeria. Of course, this is talking about the National Building Code of the Federal Republic of Nigeria. Requirement and enforcement. Requirement and enforcement. Pre-design stage. This is when the design is being birthed, when it's being conceptualized. And before that occur, this phase of analysis, this is a phase of analysis that occurs after some form of funding is available and before design begins. During the pre-design stage, studies are done to analyze space requirement issue, the constraints and the opportunities of the proposed site, the costs versus the budget. The pre-design stage may include site analysis, programming, construction cost analysis, and value engineering. Preliminary design, the design stage. Major emphasis is upon civil, mechanical, and architectural design, the design of all mechanical processes, architectural concepts, if required, are developed, and the structural system identified. Traditionally, the architect will design the building and now releases design to the engineers to work on. All the requirements, all the required site investigations are made before completing this stage. A sufficient number of drawings are then completed to communicate the design concept. The number of drawings required is strictly dependent upon the size and complexity of the project. Final design. The detailed architectural and engineering drawings, the blueprints of all physical components of the project are produced. In some complex projects, a final design report is written in addition to the blueprints, that is the drawings that are produced. Virtually all the design problems must have been resolved before the end of this final design stage. Sufficient details must be provided by the drawings and the report to allow reasonable estimates of one, the construction cost, two, operating cost. Construction scheduling is also very important. All revisions to construction materials, machineries, and equipment specifications are made. Updated schedule, cost estimates, and specifications are contained in the final design report. Construction stage. The construction stage commences after the finalization of the design. When the architect has finished his design work, the architect has passed it on to the structural engineer, the mechanical engineer, the electrical engineer, and sometimes the infrastructure engineer or the power engineer to look at and then add their own feel. The structural engineer will take charge of the structural element of the structure. The electrical engineer will take charge of the electrical element to be able to bring power into the structure and ensure that the building or the structure is well powered and functional when it comes to the electrical appliances. Not necessarily what you want, but what the client wants. The mechanical engineer also takes the architect's drawings and ensure that all the mechanical units in the structure is well managed and positioned. In a traditional model, the appointment of a contractor to undertake the construction of the facility is done. It encompasses all work on the site, that is the construction stage. Also under the construction stage, construction covers all the work required to deliver the project. The contractor, who is also a key element in the whole equation of building construction, is responsible for undertaking all the works, whether the main contractor or the subcontractor or the supply vendors. All of them are grouped as contractors because they work together to ensure and take responsibility of ensuring that the building is completed and is done as specified. Also provide provision of all material, labor, and plant and equipment. Also control the subsequent and coordination of works. Sequencing and coordination of works. And also is responsible for the coordination with the works of other parties, which includes the consultant and the client itself. Deferred liability period. I've talked about this in our last class. That period in construction, that set of time after construction after construction has been completed, during which a contractor has the right to return to site to remedy defects as it comes. A typical defect liability period lasts for 6 to 12 months, depending on how it is agreed in a contract. Defect liability period will only arise if there are issues in the contract. Also, just to mention is that defect liability period will only come to pass after practical completion has been attained and the client has taken possession of the construction project. It is very important for us to note that. The purpose of deferred liability period for the contractor, it is likely to be more economical and efficient for it to carry out remedial work itself than to pay the cost of another contractor hired by the client or the employer. From the side of the employer, the prospect, it will that the employer, the client, will not need to hire an alternate contractor to carry out the works or to carry out the work itself and claim the cost. It is very important for us to note that deferred liability period for any project is important. It helps to manage both the contractor and the client to ensure that they deliver the project as it is when due. Building design classification. Building design classification. Group A, assembly building, assembly where people come together, where they congregate, where they meet. Building without or with an auditorium in which persons assemble for amusement, entertainment, or recreation. For amusement, entertainment, or recreation. B, business use and professional uses. All building structures used for transaction of business or rendering of professional services. That's group under B. C, educational uses. All building and structure used for the business or vocational training. For the business of vocational training, e.g. schools, lecture halls, and thereabout. We also have factories and industrial uses, all buildings and structure in which occupants are engaged in performing work or labor in the fabricating, assembly, or processing of products and materials. E, high hazard, all buildings that are structure used for the manufacturing, processing, generation, or storage of corrosive, toxic, flammable, or explosive materials. Merchant building, merchant uses, all buildings or structure used for display or sales purposes, incidental, such purposes, and accessibility. To the public. H, residential uses. All buildings are structures in which families and households live, in which they sleep. Sleeping accommodations are provided for individuals with or without dining facilities. I, storage uses. All building structures primarily used for storing goods and warehouses or merchandise. J, use and occupancy. When a building is occupied by two or more uses, two or more units. Doubtful use classification. When the use of that building is not exactly specified, is not provided in this code. Utility and miscellaneous building or structures of they are buildings and structures of an accessory character and miscellaneous structures. Accessory characters when the buildings are not used for a particular purpose, they're just short used for a particular reason and then is discarded. Like site offices or thereabout. Those are utility miscellaneous. According to the International Energy Agency statistics, this is talking about energy use. For energy balance for 2004 to 2005, 2007 edition, the total final energy usage globally accounts for 7,290 megaton wax ton oil equivalent. The residential and commercial sectors account for respectively 1,951 megaton and megatons and 636 megatons respectively, which is almost 40% of the final energy used in the world. Improvement of building efficiency. That's the code. It helps to build building efficiency at planning stage is relatively simple. When you ensure that the building is more effective and efficient in any planning stage, it's always very effective. Also improve after their initial construction are much more difficult. Generally, changes when a project has been completed is a lot difficult to manage. When comparing it with the ones when it is done before it has been construction. Decision made during a building project phase determines consumption, over much of the building lifestyle. So some measure to improve efficiency are possible only during construction or by major refurbishment. Improvements will be very cost effective when improvement at project stage as compared to when it is done at a later stage of the building. The increased interest will spur the dependence for refurbishment. These refurbishments provide a compelling opportunity to improve a building efficiency. Requirements for efficiency by refurbishment are therefore an important issue which should be included in building code. Generally, what this is saying is that it is better to plan and do your energy efficient plan before the building is constructed. Because when you do that, when the building has been constructed, and you're required to make any major change, it becomes very expensive. But when you do it at the planning stage, you actually spend less to bring those things or to ensure that those things are active. Building maintenance standard. What is a building maintenance standard? Minimum standards for design, construction, and alteration to virtually every building. Developed by governments, professional bodies, etc. Contains a list of requirements that are designed to ensure minimum standard for health, safety, and welfare are held to. The purpose of the building standard is to achieve a minimum standard for building work. It applies to most types of building, including domestic, commercial, and industrial building, specifically related to the technical aspect of construction. A set standards for the design and construction of buildings. Objectives of building standards. It helps to remark with amendments, the regulation which control the design, construction, and use of the building and places of public entertainment. To describe standard for the construction and demolition of buildings, so that when building is being constructed, you do not become a menace to your neighbor. And also when building is being demolished, it doesn't cause problem to other buildings. If you are trying to demolish a skyscraper, you must do it skillfully, not so that the skyscraper does not fall on another structure, also causing any form of damage and disaster also. Prescribe standards of safety for places of public entertainment. Also regulate matters relating to the use of building and maintenance of building, and make the objectives of this building standard also describes the requirements for design and setting of single dwellings and associated building, to describe standards and matter relating to maintenance of fire service and safety measures, to describe requirements for swimming pool, spa, safety, etc. Is building regulation approval the same as obtaining building permits? It's a question. Building regulation approval does not mean the same as obtaining building planning permission for your work. Being granted planning permission is not the same as taking action to ensure that the work complies with the building regulation. Generally, you will have to adhere to building regulations for building works or internal alterations of properties, and such you may not require planning approval. That's we're talking about renovations or alterations. For many types of building work, you may need to apply for building regulation and building planning permission separately. It is very important. Those two things that must happen. That's why you have LASBAC and you have that being said, oh, good. That's the last slide for the class. This is 507. So I'll take a few questions on building code. We are going to be on building code. Before I take our questions, let's just go on a regular 5 minutes break. And then when we come back, we'll take questions. I hope that's fine with everybody.
That's okay, sir.
All right then. So we'll go on break. We'll go on break and come back by 5:15. 5:15, everybody.
Okay, sir. Thank you.
Yeah. Amen. I can see your hand, so please, your question. If you are not ready, let's go to Chimezie. Your hand is up.
Yes. Okay, sir. Thank you so much for the class. Sir.
Yes, go ahead.
Yeah, my question is, I'll need you to throw more light on that defect liability period. I didn't get it right.
Okay. I talked about this, I think, in the last class. Defect liability period refers to that time of that project where the contractor is liable to repair. It's just like guarantee or warranty. Warranty is for repairs, guarantee is for replacement where there's when anything fails. But anyway, this one is really, we call it defect liability period in buildings. It's normally a period of 6 months, and of the 5% of the total sum is held back by the client to ensure that during the period of this defect liability period, if anything goes wrong, that 5% of that cost is used to fix it if the contractor refuses to come back to site. Let's say you lay tiles in a building, and for 6 months of using that building, the tiles are perfect, no one came out, nothing got bad, your money will be paid to you. But if a few of the tiles get bad or get broken or something, or due to not somebody going to break it themselves or just by general usage, then you as a contractor, you are to go and replace or repair whatever has gone wrong at your own cost, at no cost to the client. And this period is normally between 6 months to 12 months, depend on what is agreed at the time of going into the contract. I hope I've answered your question, Chimeze.
Very, very well, sir. Thank you so much.
Are you back now? Okay. If you're not there.
Yeah, I'm here. Good evening.
Okay,
sir.
go ahead. Good evening. Your question.
Okay, my first question is, what are the building stands for? Is there a building standard in particular for Lagos State? And is this something you know that you can share?
Okay, the second one.
Okay, the second one is, I just need you to explain more on this energy efficiency, because I felt you a bit rushed. You rushed it out, so I didn't get much.
Let's go back to, let's do building standards and code. Now, there's a code for Nigeria. There's Nigeria National Building Code for Nigeria. That code is being revised as we speak now. But generally, for most engineers that are on the platform, those in the building industry, they will know that what Nigeria has been using is British standard, BS code. Because that's almost like the international standard that everybody uses. Anyway, but Nigerian code is not too far from the British standard. So if you use British standard, there is no way you go bad with the Nigerian standard. However, for some areas like cooling and warm heating, that's the mechanical part of the code. In the UK, you will be making provision for warming and heating of your house or room or whatever where you stay. But in Nigeria, there's no way you make provision for there's no weather that will get to in this country that you require warming or heating, except you are somewhere in Jos. And that's when you may require that. But generally in Nigeria, you don't need that. So those are the little amendments. There are some little amendments that happens around there in such case, just to make it, just to tropicalize it, to localize it to meet our own requirements. Then for the energy efficiency, now you agree with me that most buildings nowadays is becoming more energy efficient. And for freshly constructed buildings, at least I've been doing a lot of construction, we always advocate, maybe because of my FM experience, that imagine, okay, let me give you a live example. Now, there's a office building that I did recently, a 7-story office structure. And when the electrical engineer finished the load calculation, he now mentioned and said, okay, to run this building with generator, you require 2 500 kVA generator. And apart from the fact that those generators are heavy generators, the diesel you require to power those generators and the running cost of that generator is extremely high. Now, because of my experience, I know that you can actually run that building with a 350 or even 250 kVA generator, running it efficiently, changing all the light fittings that have been specified from regular lights to LED lights. And doing that also save money from the creating for the cables that is to be used for the structure. Because when you are using a more energy efficient lights, you don't need so much energy to run all those lights. So you save a lot of money from doing that. But if they are finished constructing the building and then they have already bought the generator and now discover that you can actually run it with 250 kVA generator, you'd have bought all the old lights. You now spend money to change all the old lights. So what I'm trying to say on the other energy efficiency is that at the time of planning stage, it's a lot easier to manage that cost to ensure that the building becomes more energy efficient, power efficient than when you have already completed the building. I hope I'm clear.
Yes, very clear.
Yeah. Thank you very much. Emmanuel, please.
Okay. Good evening. Thank you for the lecture, sir.
Yeah, good evening, sir.
My question comes from the building design classification.
Okay,
I was hoping if you could give an example with the Group D and the Group E to better clarify, because when I think of factories and industry, I also classify them as high hazard in the areas. So I would like examples to help clarify those two, that's Group D and Group E. Thank you.
Okay. for factories, and you know why it's classified separately is because there are some factories that you have that are not exactly as hazardous. If you are dealing with radioactive materials now, you cannot compare a radioactive building, a flammable building, to when you are producing cars, or when you are producing soap, or when you are producing cartons. You know, that's why it's classified separate, because that is very, you are dealing with a lot of, when you are producing chemicals, acids, and explosives, toxic, very toxic materials. That class, you need to, why is classified separately? Because for some structures, they are isolated from the general people, where people stay. If you have ever looked at where you have what do they call them? Radioactive farms, you will discover they are actually planted at the outskirts of town, because if there's any issue where there's any exposure to radiation, it is very catastrophic. That's the same thing when you have companies that produce acid, that produce inflammable material, explosives. They are also positioned that far so that you don't have that coming. You don't have those hazards coming. But general factories are things like you can just have in industrial estates, where you have industrial buildings for general production. That can be managed. That's why there's that disparity between the two of them.
Okay, thank you very much.
Yeah. Michael. Michael, let's take your question now.
Yes, please. Thank you. While the lecture was going on, I realized that on my site, I have prefabricated buildings on my site, and I don't think I've come across any maybe approved plans or something. I will check, but I don't know if there is. But I need to. It's on the free zone, so I'm not sure if it was required or anything. But I want to find out: is there a separate code for prefabricated buildings, or does these codes in this course, does it apply? That's my number one question. Then secondly, the maintenance workshop that we actually have 40-foot containers stacked on top of one another. We use them to store electrical items, plumbing items, paints, and stuff like that, with a roof that has been constructed over them. Should we have, is there a regulation, controlling this kind of structures, and where can I find them, please? Thank you.
Okay, Michael, first of all, for prefab structures or prefab buildings, is a construction methodology. So the code actually covers it. And the structural engineer, if you go to BS code that talks about structures, you will see it there. It's also covered in the code explicitly. And those for prefab materials, either you are using precast concrete, concrete walls, or insulated or prefabricated walls that you just come and assemble. All of them are covered in the building code. It's just the methodology that is that you are seeing that is just a little different for construction. Preferred is covered and covered very well in the code. And stacking of containers for storages on site. Well, it is slightly covered in the code, but generally it's just common sense that the structural engineer will give you the calculation. If you look at those containers very well on the body of the container, they give you the minimum that you can stack on them. If you look at, they have there's always a badge that is stamped on the side of the container that gives you the size, gives you the tonnage, and what you can do on top of those containers, whatever storage you can go in, and how you can stack them. So you must abide by those codes by using those containers. If you don't abide by the code, of course, you're going to have a catastrophic incidents on site. But as much as you abide by those codes that are stamped on the containers, then you don't have a problem. I hope I've been able to answer your question, Michael.
Yes, please. Thank you.
Yes. Francis, let's take you now.
Good evening, sir. Thank you for the lectures.
Thank you, sir.
So I want to know if you have to do insulation for a container.
Yes.
Is it the same material you use for sound insulation that you can use for heat? That is from the body of the wall, from the wall of the fire building, rather.
Okay. For sound insulation and heat insulation, ideally, they slightly vary, but they do about the same thing. It's about the same material we use anyway. There's this rock wool that you can use for both heat and sound. It prevents the transmission of sound and also movement of heat. Gives you a little bit of cavity in the wall so that you can be able to manage that. The materials are basically the same that you use. Then there's this other sandwich foams that you just, it's not a foam really, it's sandwich, I've forgotten the name for it, that we also use for that same insulation, both for sound and also for thermal control. If you get a refrigerator, an old refrigerator, if you open it up, the back of it, you will see that same thing covering it. That's the same material that is used for both sound and for heat.
Is that material available here? Because
yes, it's available. It's available. There's a factory somewhere in Ikeja that they produce it. I used it some 8 or 10 years ago. I can't remember. It's been
maybe
long.
They are no more there.
No, I think they will still be there. Those who won't go out of the country. I used it some 8-10 years ago for a particular project where I needed to do. We built a customized cold room for storing reagents for them in a particular place. I did the project in Ikoyi some 8-10 years ago, and we had to do that cold room. And also, apart from building the cold room, we also insulated the wall around so that we won't have condensation going out to the other part to maintain and that.
I'm trying to construct a container for a site, for drivers rather. So I'm finding it difficult. I've opted for a foam material, normal foam that they use for furniture, because I couldn't find this.
Normal foam will not. We may just do a little bit of sound insulation, but it may not be effective for thermal though. But it will work. If it's for drivers, it will work because they're not going to stay there for too long. It's just for a short period. However, you can mix it. You can mix that with rock wool. Rock wool.
Okay, can that be easily got into?
Yes, you can easily get rock wool. If you type rock wool on the internet, Google where to get it in Nigeria, you get it easily.
Okay, sir. All right. So that's my first question. But concerning the Ikeja one, sir, can you please let me find out if you remember?
Okay, I'll find out. I'll get back. Yes, I'll find out.
All right, sir. Thank you, sir. So the second question, this energy efficiency.
Yes, sir.
I see that most times we always talk about to reduce the energy cost. We always talk about changing bulbs to energy saving bulbs.
Not just that.
If you plan. Okay, so because most time is the energy bulb that we talk. So I'm going to ask, if you have a 21 unit of 3-bedroom flat,
yes,
and it's already built, so it's easier for you to do the common area and say, let's change this to energy saving, let's remove this cable and put a lighter one. How about the indoor? You can't tell a client, though they are the one paying for it, you can advise them if they agree, but if one party agree, the other does not agree, and your cost is still the same thing.
Okay, let me advise on that axis. When it comes to energy efficiency in terms of cost, I expect that your individual clients in that kind of unit are billed separately. Their energy consumption is billed to them separately. So if they want to be paying very high bills, well, why not? If not, you leave them now. They are rich men. But if it's touching their pocket and they know. You're not the one doing it now. You are the facility manager. You're only just controlling the cost, and you're advising them. Oh, if you are spending 150,000 for your bills every month, and you feel that if you give them, if they become more energy efficient, they will spend as low as 50,000 It's only a madman that would say no. It's only a mad. It's the truth.
You can always go and advise each.
You can advise
each
them
apartment.
each apartment, yes, because they are the ones they are the ones paying for the energy consumption anyway, not you.
Yes.
Except you are the one paying. If you are paying, then you are for the Christmas now. It's all right. I think I would like to be like you when I grew up.
So it's better you just concentrate on the common areas and
yes,
because when you have to do audit, when they have to audit you on how you spend your money, they won't tell you. They will, because there are bills. Of course, there will be meter like Mr. Paul advice.
There must be
meter. The common area
meter the common.
All right, fantastic. Yes, thank you, sir.
Okay, Callisto, sir.
KUs.
Okay.
Yeah, thank you. Okay, thank you, sir. So I have 2 or 3 questions, depending on how you look at it. Now, my first question is on the building code. Is there any agency in enforcing this code? Or is this code just one of those policies we have something? Hello?
In Lagos, last back.
Hello, sir.
Hello, I said in Lagos, the enforcement unit is last back.
Okay. In Abuja, which unit? I'm not in
Abuja. I think they have Abuja municipal, whatever building management agency that comes to every site. I know they visit every site in Abuja. I can't remember their name.
I want to believe the Development Control Authority should be the one enforcing this building code.
Of course, yes. That's where it comes from.
Okay. Now, from this building code, a lot of professionals are involved. The architects, the engineer, the structural, the mechanical, the electrical engineer. Now, in a situation where you have conflict of interest, whose position supersedes others? Who have the final say on this building code?
Conflict of interest. How do you mean conflict of interest? Please,
now, if, for example, an architect for aesthetics values design something, the structural engineer, for one reason or the other, say it should not fly. Even when it seems to be stay within the building code. How do we resolve such issues?
Okay, first of all, let me answer first. Don't crowd yourself. First of all, the architect is the head of the building team.
Okay.
1. Then 2, the engineer did not design the building. He only designs based on the architect's design. So the architect is the generator, is the one that brings the concept that the engineer is working with. So the engineer is actually supposed to listen to the architect and ensure that the architect design is workable, not bringing his own idea into the architect's concept. If the architect is not accepting the idea the engineer is bringing, it is the onus lie on the engineer to solve the architect's problem. The engineer is only just being lazy by not being able to solve the architect's problem.
Okay, sometimes a situation might arise that some of the things the architect wants is beyond each profession have its own limitations, whether by experience or by specification. So in a situation whereby architect what is demanding is beyond has limitations either by the experience of the designer or the environmental factors self, in such case, I believe some level of
it's not true. The engineer is not experienced. It should change engineer. Simple.
Okay. Now, let me. I can see you're talking as an architect.
Because I'm an architect now. I'm just telling you. I'm telling you the truth. No, hold on. I've seen this thing over and over again. I've worked with several engineers in my life, and I can tell you for free, there are some engineers that are conservative. Why some? There are some that they are ready to take risks. Some they don't want to take risks. The ones that are not wanting to take risks, and you have there are iconic buildings in this world. And those iconic buildings came up because somebody was able to stretch the limit. If the architect has given a design and the engineer is not able to mentally work it out, the engineer is deficient in terms of mental capacity. That is not the fault of the architect. Except the engineer is able to sell his own restricted idea to the architect, and the architect decided to go and change his design to amend to fit the engineer's laziness, then okay, that's possible. But however, if the architect knows exactly what he's doing, if he's an experienced architect that has worked over the years, he will know where these boundaries are and what the materials are that will be able to do it. Nobody had ever said that they've known that an auditorium that can seat 150 or 500,000 people will be able to span the roof without having a beam, or rather having a column in between at the center. Go to Abuja, what's it called? Dunamis, have it there. If you talk to local engineers, they'll tell you, no, it's not possible. But the ones that have done it, are they fools? So it's just the laziness of the engineers that probably they don't want to stretch their boundaries. That's all. You can excuse them, but just leave them alone and get the ones that are intelligent enough to handle the problem.
Okay. Now, my second question is on the issue of energy efficiency.
Yes, sir.
Now, since the architect is the one that initiates this building by virtue of his design, I want to know, how does the architect ensure this energy efficiency? And how can you guide, especially the electrical and the mechanical engineer, to ensure this energy efficiency? Since it is something we have to take care of from the design stage, it's the best taken care at the design stage. And beyond this energy bulb, what else in terms of, take for example, are you in position to advise, take for example, an electrical engineer decide to put 5 bulbs, whether they are energy or not, in a sitting room. What can the architect do to reduce that 5 bulbs to 3 bulbs, for example?
But somehow, I think the reverse, that question is actually on the reverse. It's the architect that will want more light than the engineer. The engineer will always design less light. And in terms of the wattage and the, what's it called? Because the architects normally design and put the moods in, especially in the interiors of a building. I give you an example. I'm on a project where the architect has finished his work. For very large projects, except the architect is very experienced and is spot on. That's when he'll be able to go critically into what the electrical engineer is designing in terms of lighting. Especially if the architect, you see, there are different kinds of architects. There are those that are very conservative, that does the external structure, they do high-rise offices. There are those that actually specialize in interior design, not the ones that are branding themselves up and down everywhere now in Lagos, in Abuja, interior decor, interior design. No, those are just furniture sellers. No, the ones that actually design the space and make the space very functional. Every element of the space, the thinking process behind the electrical sockets and switches, the bulbs, the position of the switches, the position of the light, the color of the room, every single detail, the floor, the ceiling height, and every single detail is designed to ensure that it meets the client's requirement. Now, ideally, the architect is supposed to work closely with the engineers, but sometimes because of pride of this engineer, just do it and they send their drawings. And even the architect is also lazy not to check and scrutinize what the engineers have done. If you meet a client that is well-schooled, I'm telling you, you'll be shocked that the architect will decide every single element in that building. Because it's the architect's design, he will tell you the kind of lights that you're supposed to provide there. The electrician cannot just come and say, okay, I'm putting 1 bulb here. Okay, you are putting 1 bulb. Have you looked at the interiors? How do you manage it? And then the more light you have, it gives the ambient space. You can create moods. And creating moods also, looking at the energy efficiency of the building, you cannot decide the kind of lighting you use. There are a lot of LED lightings now that are very energy efficient. In fact, a lot of things that it doesn't make sense for you to just build building, and refrigerators are becoming inverter direct, air conditioning system, your microwaves, your washing machines, everything is becoming very energy efficient. But it's just that in Nigeria, we're always carrying last. We come after the world has passed it. Other part of the world, Mr. Paul has this meter that they use to check. Once you plug it, it will show you how efficient your usage of energy in your house is and advise you on how to manage it. Ideally, the architect will advise the client and also advise the engineer on how to go about this. The architect is supposed to give direction to the engineer so that the engineer will know exactly what he needs to do. If the architect is a green certified architect, it will make the life a lot easier to make the building energy efficient, because you will want to go green and use less energy so that you can actually make that building a lot lighter in terms of energy efficiency and power consumption.
Okay, sir. So from what you're saying now, it is actually the architect that's supposed to initiate the energy efficiency and not the other way around.
Yes,
okay.
That's the truth. But the engineer can be smart enough to do that with his knowledge, but it's really not the engineer's job. It is the engineer actually takes instruction from the architect. I don't know if you understand.
Yes, yes. Okay, thank you.
Yeah. Your hand is still up. Do you still have your question?
Yes.
Please go ahead then.
So now from this conversation, can you hear me?
Yes, I can hear you.
Okay, good. So I want to ask, how long should an architect be on site? Because now you are saying he has to direct the engineer. Because
the architect has to be on site. No. You see, that's the problem. It's because we don't work with standard. The architect is supposed to monitor that building from the beginning to the end. It's because most clients do not want to pay the architect's fee. That's why the architect will just design and give you drawings and drop it and walk away. Collect his money for drawings. There's stage 1, stage 2, stage 3. Stage 3 is the design, is the monitoring process. That's where you have the monitoring and control of the building to ensure that everything is done to the latter and before the building closes. Any serious client will ensure that the architect is on the project till the end. In fact, by standard, the most advanced countries, architects are always given the role of the prime consultant so that they will have no excuse by the time the building is completed to tell you that you did not follow my design.
Okay, that's good. Then also, I have another question concerning this. On the island, there's a general problem that is going on with POP falling off. It seems like it's a common thing in most of these new estates. So I don't know, where is this fault coming from? Because most times
bad workmanship.
Bad workmanship. Okay. All
because
right.
I've done projects for like that have been standing for 15, 20 years and it has never fallen off.
These are houses of like a year and 2 years. And
I'm telling you that it's not developers. It's developers that have built it now. Bad workmanship.
Okay. Then one last one. On this energy efficiency, aside from the light bulbs and AC, which everybody know now, are there any other equipment that would help me bringing down energy costs?
Madam, I've mentioned
maybe like wires or
no wire. Madam, if you are using, if you do your studies very well, you will use less. Where you are supposed to use maybe 4 mm cable for running normal air conditioner. If you are using the energy saver one, you don't need that. You just see the specification. It's written on the body of the equipment. They'll tell you the specification there. Use less. So once you are cutting down those costs, but it's just that this thing has to be planned. You don't just wake up to do it. You plan it accordingly so that when you are installing it, that's when you begin to see the merit of the savings that you have probably gotten.
She can also, excuse me, sir. She can also, can I say something, sir, please? I'm sorry, man. I just want to add to your answer or maybe her questions. Can also use smart lighting, like passages where people are not always there. You install smart lights when there's nobody, is off. When somebody approaches, it comes on. So it's not constantly on. That's another method you can also use to cut down your energy use.
Okay.
Yeah, it's called motion detectors.
Yeah. Motion detectors that is attached to the lightings. That's good. Awe, let's take your question.
Thank you so much, sir. Hello, sir.
Yeah, go ahead. I can hear you.
Yeah, in this regulatory and standard, so what is it related with urban and regional planners? That's my first question.
I didn't get that. Sorry, take that again.
I said with this regulatory and standard
Yeah, building code and everything.
Yes. Is it anywhere related to urban and regional planners?
Of course, now.
Okay, so what's the aspect of urban planners?
What's the aspect of urban planning?
Yes, urban planners.
It's a code now. Inside that code, you will see the part where you have to do, where you are doing regional planning. It specifies the sizes of plot, the sizes of road, the minimum requirements you have to make, the provision for minimal estates, for towns, for urban areas, for the number of schools that you need to provide for, the number of churches or something, recreational centers, games area, green areas. Those things are code. They are the codes in those things now for urban and regional planners. It's not something that falls from the sky. If you studied urban and regional planning, you will know these things by your fingertips. By every number of unit of building, you know that you need to make provision for the number of the drainage and all that. You need to, those things are code. They are inside the code for you to use.
Okay, sir. And then number 2 question is, what is the standard size of the plot? Is it 60 by 120 or 550 by 100?
Well, it depends on the area. For Lagos region, it's actually 60 by 120. For some places outside Lagos, it's 50 by 100.
Okay, but it varies depending on states.
That's what I've said now. That
okay,
every
sir.
state
Yeah,
is localized and have their own.
Yeah, the last question is, not like me citing an example. Like here now in everybody that is conversant with MMA2, there is one hotel that's about 10 floors that has been abandoned. The reason why the hotel was abandoned was they said an hotel in that vicinity is not okay. You know, they can easily trace people, and anything that happens there might affect the operation of the airport. But the construction has got to the 7th floor. And from the initial, is it that the regulatory commission didn't do their work, or when the construction was ongoing, they found another policy that contradicts what was originally approved, because the building was approved before it can be initiated. So I'm just trying to know that is there like any upgrade in the policy? Maybe something will be approved today, then tomorrow another policy comes that supersedes the existing one. That's the question, sir.
Okay, the last time I checked, I'm not the governor of Lagos State. You know about the president of Federal of Nigeria, Federal Republic of Nigeria. But in terms of those things happening, well, the only thing I can say is that such things does happen. But again, the siting of a hotel close to the airport, I don't see anything wrong with it. And maybe the person involved have offended the gods and they decide to punish him. So because several places all over the world, you have hotels that are close to airports and thereabouts. So it will actually function well as a stopover for when you have a flight at middle of the night and you want to just sleep over at the hotel. Just go there, lodge, and finish and go into the airport. But however, I don't have the details of what has transpired in that particular incident, so I will not be able to tell you exactly what has happened. But the only thing I can say is that policies can change from time to time. People can do things as they like when you're in government. If you offend the person that is there, the commissioner of aviation, you can decide to punish you, but that's not my business. In terms of building code, which is related to me, what it will just consider is the structure itself. That structure, is it feasible? Is it workable? And if the answer is yes, he passes it. If the answer is no, he says no. But in terms of that financial discussion or financial question, well, the thing has been done. I don't have details of that transaction, so I cannot exactly speak about that. You know.
Okay, but policy can change anytime depending.
Of course, policy can change now.
Okay, that's the question. Thanks so much.
All right.
Sorry, sir. Excuse me. This is Francis.
Yes, go ahead.
Mr. Ware, I think you should. I don't know if you are so close to maybe the client, the ownership of that hotel. You should go and find out. It may not be a policy change. It may be that they contradicted the building code. So let me give you an example. Lekki Gardens. I don't know if you heard about Lekki Gardens, a very big real estate company. They will get approval for a 4-story building, and after the last decade, they will put 2 more stories. So it may be the same thing. Since you are saying that they've gotten to 7th floor, and see, if a barracks is close to you, you can't build an high-rise that will be seen inside the barrack. I think the same applies to airports.
Air Force Base is near that side too.
So that is the reason. That is the reason. It's not they compromise the standard. It's not that the government has changed. No. Go and find out where you realize that they compromise. You can't get to the level that you can see everything happening at Air Force Base or a military base. It is wrong in any part of the world. That is what I learned.
Anyway,
well, you are very correct. However, why I said I cannot talk in because I don't have that detail yet. If I have that detail, I'll be able to advise exactly. So, but that being as it were, if that contradicts it, I'm telling you that if that thing actually contradicts what you are saying is contradicting, that building would have been brought down. It would have been brought down immediately once it's a security risk. For the government, I know they will take it down.
So either they bring it down or
because
they
right
leave it
now,
unused.
If you leave it unused, it's even more dangerous.
It's still, yes.
So they'll take it. If it's security risk, they'll take it down. So let's just leave that as it is.
So, sir, I want to ask, when you were talking about the architect being the head of the project team, and you said any client that does not put the architect to work from the beginning of the project to the end means he doesn't want to pay or something. Is there a standard for costs for each of these professionals? Because in Nigeria, we don't have price control.
It's a lie. There's a scale of fees. Clients do not pay.
Okay, so where do we get this cost? So that if I'm getting a structure, an architect to do a 7 unit.
Wait, hold on. The architects always have the scale of fees. If you are consulting me, by the time you will finish talking, I will send you my scale of fees, which will show you what you pay the architect, what you pay the structural engineer, what you pay the electrical engineer, what you pay the mechanical engineer, even the
you will be the one to send the scale of fees.
Yes, I'll send it. It's a standard now. That's what I'll use to calculate my
fees. Everybody.
Yes.
Not just for you, but for all the other engineers, right?
Okay. Like I said, it's a scale of fees. It's standard.
Okay. So
every qualified architect has it.
Okay. But it's something you can negotiate, even if it's a sound.
You see yourself. You have seen yourself now. You see yourself. That's where you're trying to. You want
is that something they don't negotiate?
Every businessman must negotiate.
Wait, hold on, calm down. You see, that's where we always have a problem. By the time, yes, I'm not saying you will negotiate, you can negotiate. But however, what I'm saying is that when you are negotiating, you are going to pay for that your negotiation you are doing, because you will not be able to hold the architect to do what he's supposed to do, because you're not paying him his complete fees.
Once he agrees on my negotiated price, then
you don't even know. You are not schooled, so you won't know exactly what the architect
exactly, sir. It's the reason why I said there is no price. So if you tell me it's 100,000 naira that I used to do this work, and I say I can pay 80, I agree.
Sorry, you see, you are the wrong. Any design will cost you from that scale of fees nothing less than 3 million naira for the cheapest.
No, I'm just using 100,000 as an example. Say,
so if you pay somebody now, if you pay somebody 100,000 naira and you now want the person to give you the work of 10 million naira, how will you get it?
No, that's not what I'm saying. If you have given me your scale of fees and it's showing 3 million naira, and I say I can pay 2.5, and you agree,
okay, you get 2.5 work.
So you are the one that is not doing the right thing then.
It's because you don't know. If you know, you will pay the company. That's what I'm telling you. You are negotiating to your detriment. That's what always have been happening. You do not understand.
So I don't know, sir. I understand this part, and I used to tell people that if you tell somebody that you want to buy something, and he tell you 20,000, for instance. Igbo. I used to mention Igbo. My wife is Igbo, so nobody should crucify me.
Okay, wait. Before you go very
Igbo man will not want to take the money away.
See, let me tell you, by international standard, if you submit a quotation, the highest you can go, that you can go in that quotation they have submitted is 5%. If you go above 5% discount, you'll be seen as a thief.
Okay. So the client will be seen as a thief.
You as a person that is supporting that is submitting the quotation.
Yes. Okay. Okay. So if it's a standard, I understand now. We're gonna look for the scale of fees and know the exact standard. Because of course you won't show me the scale of fees, you only quote for me.
See, ideally,
is that right, sir?
Wait, hold on. No, you're not right. Okay. If you consult me as an architect and
yes,
you give me your project and everything that we have discussed and we have agreed. Normally, what I will do the computation and give you the cost. This is what I will do, the spreadsheet for you. There's a spreadsheet for it and submit to you. Most people, immediately they see that thing, they will just switch up. They won't call you again.
Yeah.
So that's the problem. So by the time you do
because most of us are not sensitized about this scale of fees. I'm just hearing it for the first time.
Okay. Are you an engineer?
I am not. In our mind, we believe there is no price control standard in Nigeria. So just negotiate according. So we believe that if you tell me 100,000,
okay, let me tell you the truth. As an architect, I've seen a lot of clients. One day I met a client that wanted to do a design, but I gave the client a charge of 1.3 million naira. He said, "Oh, that is too much." Oh,
yeah.
I just told the person very well. Go to Unilag, go to Department of Architecture. You will see students there that will take 50,000 naira from you to do your design. Please go and meet them to do it. You cannot be looking at me that I've gotten how many years of experience. I will take that kind of money from you. Am I a fool? You don't know the wealth of experience I'm going to bring into your design. And when I schooled the client went mute. It was, in fact, the client had to pay me more than what I even charged initially. Okay, I told him, go to Unilag now. There's no problem. Go there. I go and get students inside Unilag and get the architecture student to design for you now. So you want fine house. Go and design. They'll design it, then they'll come back. By the time you finish building the building, you now discover it's not functional. So that's what normally happens. If you do not understand what you want, that's why at the end of the day, professionals are leaving Nigeria. Doctors, every engineers, because they don't know what they carry. They don't know what their price, what is their price mark on the profession. You see a barrister. Yes, that's why you can, outside the country, to get a plumber to come and do work for you, you will know how much you will pay. Then talk less of an architect. So it's because we don't know. That's why we behave.
That's why I said Nigeria perspective now.
Not Nigeria perspective. It's because we decide to do what is wrong. If you do what is right, you will discover that.
We decide not to use standard. Yes.
Okay. Oh.
You're right. You're right, sir. Thank you.
Yeah, thank you very much. Thanks for the lecture, and good evening, everyone. Well, mine is just like an additional information. As a standard person, I want to just say a few things concerning the National Building Code, the standards. Just addition to what you have said. The National Building Code is a document that was developed under the federal government. Currently is the Federal Ministry of Works that maintains, that has a custodian of that particular document. And so they maintain the document. And what I mean by maintaining the document is that they make sure that maybe it's still relevant, maybe when it needs review, just like it's being reviewed right now, they ensure that it is reviewed and the relevant stakeholders are involved. However, it's the states that implement and enforce the National Building Code using the various names that they decide to use according to whatever the state requires to use. But whatever the state is doing at the state level is the National Building Code that they are trying to enforce. And the National Building Code just sets the minimum requirements, just like the lecturer has told us this evening, for constructions. And so it's the states that enforce the National Building Code. And the National Building Code, when it was developed, made references to so many standards, international standards, particularly British standards, okay? And now some of those British standards are no longer in existence because with technological improvements and new things happening, there are new ways of doing things better, like we are talking about energy efficiency right now. So because of that, so the National Building Code of Nigeria is quite not relevant. When I mean not relevant, it's not up to date, it's not updated, and that was why it's been reviewed. So some of those standards are obsolete, some of them have been reviewed and have better content, and we are still making reference to the old one. That was why the National Building Code was reviewed. It has actually been reviewed, but I think at the last stage, we were trying to say, okay, it's so large, it's so big, because we looked at why are the standards, the National Building Code, not being implemented with so much enthusiasm. The document is huge, just like we were told in one of the lectures, the classes, that even we can't even, the soft copy is huge. So what we're trying to do now is to break them down according to specific sections and areas to make them more accessible and usable. So that's what we're trying to do now. So the National Building Code, what I'm trying to say is, National Building Code is the national document, but it's being enforced by the states using whatever authority they want to use to do that. But it's the National Building Code they're enforcing. The National Building Code has been reviewed to be updated to the current situations in the building industry and building and construction industry. And so what the engineers and even the Federal Ministry of Works is trying to do now, working with the Standards Organization of Nigeria, is to break down those things so that when it comes to electrical works and the requirements, you can easily pick it up. The electrical engineer can quickly pick it up and use it to guide him or her on the electrical works. And it makes even those who are enforcing this thing, makes the document more accessible for them to enforce with so much ease, from the point of knowing, from the point of information that they have. So that's I just wanted to add a little to what the lecturer has told us this evening. I work with the Standards Organization of Nigeria. I just wanted to make that clarification. Thank you very much for the opportunity.
Madam, just thank you very much. It was apt and exactly what I was trying to drive across. But again, since you are there, I talked to a few of my friends that also work in the Standard Organization of Nigeria, and why that code and that National Building Code of Nigeria, that the one we use in Nigeria, is not very popular, is because it's not being taught in schools. Yeah. And that's one. Then two, most engineers till tomorrow, I still review engineering drawings. What they quote is a British code, BS code. They need to go back to ensure that from the universities, they start referencing Nigerian building code. And once they start doing that, then it is easy for them to get used to it. Like for me, I have different sections of the British code, which I use for reference anyway. I think I have part of the Nigerian National Building Code, which somebody sent to me a long time ago, but it's the old one in 2006. I'm waiting for this review to finish. And then once it comes, each code, no matter how you look at it, a lot of them are sectionized. But Nigeria is so funny. When Nigeria was producing its own, they just merged everything together to make it one. And that's why it became a problem. British code is sectionized, is broken into different sections. That's why different people can, the code, British BS code that is the structural engineer we use is different from the one the electrical engineer we use, is different from the one the mechanical engineer we use, but it's the same code, but it's just like sectionized for them. That's what Nigeria should have done, but Nigeria just clumped everything together to make, I don't know what they're trying to achieve anyway, but God
anyway, we're trying to sanitize it. We're trying to bring that orderliness and sectionize it.
Saying, madam, that's what you're saying. I've heard it for the past 10 years.
No. This one, in the last 1, 2, 3 years, we've been working with the Ministry of Works and all the engineers.
Madam, I know that. I'm the one that told you that I know that it's being reviewed because I know my people told me now.
Yeah.
I know. So, but I'm just saying that I've been here for the past 10 years.
No
but it's all right.
We'll get there. Thank you.
Thank you very much. Yes. Any more questions? So, Francis, your hand.
Madam, the National Building Code, that is in Nigeria, we can just assume that is the minimum standard. So the people using the BS code, it's no offense, right?
Well, like, when it comes to
the lecturer said.
No, when it comes to standards, you're expected to use the Nigerian standard. Make mention of Nigerian standard. Yes. But the truth is that those who are using the British one are doing the wrong thing.
So if the Nigerian standard is not up to date, like you said, for instance, technology has taken over so many things, and you are still, and I want to do that in my own building. So is an offense?
No. It's being reviewed now. Like the lecturer said.
Pending when it will be completely reviewed.
Because even what you're mentioning, those British standards are the reviewed, updated British standards. You understand? Yes, because
I
if you go to the
understand.
ones that, if you go to the the Nigerian National Building Code, you will see standards of 1950, 1940. They were referenced in that building code.
Very correct.
Yes.
That's what is there.
Yes, you see it in that building code, but we are trying to update it to go to the current standards. The standards are available because we cannot reinvent the wheel. Standards have been set, just like the lecturer said. We just consider maybe the weather, our practices, our topography, and whatever. That's what we consider to see. That's the only difference. If not, they've been set and you can use them. Okay. So whoever is making reference to the updated English British standard, and that's what we want to update so that we can make reference to those standards, and then people can make reference to the Nigerian National Building Code, and indirectly making reference to the British one. So it's been updated.
Yes.
In fact, it's actually been updated completely. I think they are waiting for the approval from, I don't know whether it's the National Assembly or whatever. So that's
sorry. I want to get something clear. Hello.
Yeah, I'm listening.
Go ahead.
Yeah, I want to get something clear. There's so much noise somewhere. I am an engineer.
Okay, I can't hear anybody again. Who's talking?
Hello.
Yeah, go ahead.
Hello.
Yes.
Okay. I am an engineer, a civil and a structural engineer. And when we talk about British code, we're talking about design code.
Yes, design.
The building code we have, because I think I've cited and I've gone through it, is not talking about design. It's talking about general guide to regard to production of buildings.
Okay.
But
sorry, you're making a mistake. It's both. Okay. It contains both. If you look at the British code, that BS code that you use, if you still go into the only one that is interesting you is the design code for the elements that you are using to design. In Nigeria, also the National Building Code also has it. It also has it. So you need to also go through the code to go to where you have the design code in the National Building Code. It's because you are conversant with the BS code design one. That's why you are easily referring to it. Because that's what you are taught in the university. That's what you are taught in schools. So everybody refers to it easily as the standard code. In America, if you go and code BS code, they'll throw your document away.
You're very right. It's wrong.
So that's the issue.
Well, we look forward, just like you rightly observed, we look forward to update it. As a matter of fact, some of us have even moved to using Euro code. I'm coming because when we are talking about national code, they are not updated. And as you rightly observe, we can be reviewing a code over 10 years.
Yes, doesn't make sense.
So these are issues. If we really, in addition to teaching it in school, we should be up to the date as much as possible. And again, sir, how localized? Because even we as engineers, we're even questioning the British code and code, because the result of those codes are a result of experiment done in overseas with their materials that are not common with us here.
Okay, let me tell you a very simple one that has been an issue till tomorrow is that copper wire.
Yes, sir.
The copper we produce in Nigeria is far better than any copper that is produced anywhere in the world.
Correct.
How come we are not using that copper to be the standard? And yet people will go and import wires from UK and come to Nigeria to come and install here.
You see?
It doesn't make sense. Sometimes I don't understand our own thinking, because it has been proven but at least I know that I've been in the industry for quite a number of years. At least for the past 15, 20 years that I've been doing some work. In fact, till recently that I did a particular office for a multinational, they sent their experts to come and do there's this test they do for cables. And they were shocked. It was Nigerian cable, Nigeria chip. The reading was far higher than what they get in Britain. And they had to just certify the thing straight up. No questions. Because of that. But we don't even believe ourselves. Talking about
because Nigerians want to use cheap materials. Do you know, it may interest you to know that people go outside this country, tell people in China to do something and put Najachin on it and put it made in Nigeria.
Of
and
course.
at the front, you will see it made in Nigeria. So most times when we see such things, we seize them because they know that the Nigerian cables are the best in the world. I can proudly say because we had to work with them. They did self-regulation. They got to where they are now. And that is it. But because people want cheap articles, they go for the cheap ones, the Chinese whatever, and they don't want to make use of Nigerian cables. We have a good standard for Nigerian cables, and the manufacturers are living up to expectations, and in fact, the best in the world. So it's just Nigeria. We know we like anything foreign that is coming from overseas, whether it is
okay. Thank you very much. That's not part of the class. All right, let's take a okay. Francis, let me see your hand quickly. Let's take your own. Let's leave this UK and
sorry, I'm supposed to have lowered my hand. I'm done with the question, sir.
All right, thanks. All right, who else? Okay. Any other question or contribution?
Thank you very much, sir. Thank you.
Okay.
Well. Yeah.
All right. Thank you very much for your time. I hope that with this viewpoint of mine, you have enjoyed the class.
I really appreciate you. I appreciate the class.
Thank you very much, sir. Thank you very much for your time, and God bless you. Yeah. Have a great day.
Thank you, sir. Bye.
Thank you so much.
Bye, everyone. Enjoy the rest of the weekend. Bye.
Yeah, bye now.
Bye.
Bye.